Radiation and effects. Radiation is defined as transmission of energy from one place to another without a media. Ionizing radiation is radiation with sufficient energy to strip electrons from atoms in the media through which it passes. Examples are alpha particles, beta particles, X-rays and gamma rays. Non-ionizing radiation is radiation which is not capable of stripping electrons from atoms of the media through which it passes. Examples include radio waves, microwaves, visible light, infrared waves and ultraviolet radiation. Ionizing radiation is the energy produced from natural and man-made radioactive materials. It is present in the environment because of naturally occurring radioactive minerals remaining from the very early formation of the planet. This leads to exposure to gamma rays and radioactive radon gas from certain rocks and from radioactive material in our food and drink. Also, we are exposed to natural ionizing radiation that comes from outer space and passes through the atmosphere of the planet, so-called cosmic radiation. There are three main sources of man-made ionizing radiation. First, it is used in medicine for treating cancer and for the diagnosis of many diseases. Second, radioactive materials are also used in industry, primarily for measurement and testing purposes and in atomic reactors for producing electricity. Both medical and industrial uses of radiation produce radioactive waste. Third, it is present as fallout from previous nuclear weapon explosions and other incidents worldwide. A study conducted by NRPB, National Radiological Protection Board, UK estimates that exposure of UK population to ionizing radiations are caused by natural sources, 85%, and only 15% caused by man-made sources. Radiations in the environment that come from sunlight, power lines, electrical equipment and mobile phone systems do not have enough energy to produce these ionizations. Therefore, they are called non-ionizing radiations. Ionizing radiations in the refinery. Materials that can emit ionizing radiations are called radioactive isotopes. We use isotopes for some instruments and testing. Examples: AMART level transmitters used in H-oil unit. Some ionizing type smoke detectors use isotopes, but in very low rates, say few pQries. X-ray scanners used in the security section use radioactive isotopes. X-ray units used by NDT section also use isotopes. Radiation protection, time, distance and shielding are the main considerations to minimize radiation hazards. Minimize the time of exposure, increase the distance and use proper shielding. ALARA as low as reasonably achievable, a process that applies a graded approach to reducing dose levels to workers and the public and reducing releases of radioactive materials to the environment. The goal of this process, often referred to as ALARA, is not merely to reduce doses, but to reduce them to levels that are as low as reasonably achievable. Effects of radiation. Alpha, beta, and gamma rays also cause damage to living matter, in varying degrees. Alpha particles have a very small absorption range, and thus are usually not harmful to life, unless ingested, due to its high ionizing power. Beta particles are also damaging to DNA, and therefore are often used in radiation therapy to mutate and kill cancer cells. Gamma rays are often considered the most dangerous type of radiation to living matter. Unlike alpha and beta particles, which are charged particles, gamma rays are instead forms of energy. They have large penetrating range and can diffuse through many cells before dissipating, causing widespread damage such as radiation sickness. Because gamma rays have such high penetrating power and can damage living cells to a great extent, they are often used in irradiation, a process used to kill living organisms. Radiography. Following are the radioactive materials used in our refinery by NDT section: cobalt-60, iridium-192, and cesium-137. Radiation protection to the radiographers and others are provided by two basic concepts. 1. Radiation survey meters. These are portable instruments that detect and measure radiation dose rates and measured in dose per unit time. Generally this will read from 0.1 rem up to 1000 mrem. Rem is the unit of radiation dose. Mrem equals milliroentgen equivalent in man. 2. Dosimeters. Film badge. These are radiation measurement devices that usually are carried on the body of the radiographer. The level of exposure can be identified from these film. Pocket dosimeter ionizing chamber tube. These instruments can be read directly by the radiographer. Radiography can be harmful to personnel if carried out incorrectly. It is essential that proper control of storage, handling and use of radioactive isotopes are exercised. To accomplish this, following rules and regulations have been adopted by KNPC. How can you work safely around radiation? Use time, distance, shielding, and containment to reduce exposure. Wear dosimeters, for example, film or TLD badges, if issued. Avoid contact with the contamination. Wear protective clothing that, if contaminated, can be removed. Wash with non-abrasive soap and water any part of the body that may have come in contact with the contamination. Assume that all materials, equipment, and personnel that came in contact with the contamination are contaminated. Radiological monitoring is recommended before leaving the scene. Rules to remember when working with radiation. Everyone must take radiation overexposure seriously. Hence, preventive measures and rules must be strictly followed to avoid critical health conditions. Acquire adequate training to better understand the nature of radiation hazards. Reduce handling time of radioactive materials and equipment. Be mindful of your distance from sources of radiation. Increase distance as much as possible. Use proper shielding for the type of radiation. Isolate or contain harmful radioactive materials properly. Armor yourself with appropriate protective clothing and dosimeters. Conduct contamination surveys in the work area. Do not eat, drink, smoke, or apply cosmetics in an area where unsealed radioactive substances are handled. Observe proper radioactive waste disposal. Conduct regular radiation safety self-inspections. What type of radiation? Alpha. These are fast-moving helium atoms. They have high energy, typically in the MeV range, but due to their large mass, they are stopped by just a few inches of air, or a piece of paper. Beta. These are fast-moving electrons. They typically have energies in the range of a few hundred keV to several MeV. Since electrons are much lighter than helium atoms, they are able to penetrate further, through several feet of air, or several millimeters of plastic or less of very light metals. Gamma. These are photons, just like light, except of much higher energy, typically from several keV to several MeV. X-rays and gamma rays are really the same thing, the difference is how they were produced. Depending on their energy, they can be stopped by a thin piece of aluminum foil, or they can penetrate several inches of lead. What are the 7 types of radiation? Radio waves, instant communication. Microwaves, data and heat. Infrared waves, invisible heat. Visible light rays. Ultraviolet waves, energetic light. X-rays, penetrating radiation. Gamma rays, nuclear energy. Storage. 1. Isotopes must always be kept in the storage pit when not in use. 2. The storage pit must always be kept locked and the key placed in the NDT section office. 3. Isotopes must never be left unattended, like in the back of vehicles etc. Handling and use. 1. When using isotopes to carry out radiography, care must always be taken to avoid direction of the radiation beam towards personnel. 2. The area of exposure must always be identified by means of rope barriers with radiation signs and warning notices. 3. The dose rate on the barrier should not exceed 5 mrems, hour. 4. The operator concerned should withdraw from the exposure area immediately when the exposure commences, and he must always be available should it be necessary to terminate the exposure due to unit shutdown or other emergencies. 5. Personnel safety film badges and dosimeters must be carried at all times by staff carrying out radiography.
Please give comment and suggestions.
Thank you.
Subscribe our YouTube channel and hit the bell icon for more updates. Thank for visit our channel. See you next class.
Thank you.